Hello everyone, welcome back to problem 2. If you haven't seen the first video, we're going to be writing this in Python. This is meant for people who already sort of know how to code and the basic data structures, especially this problem because it involves linked lists. You will probably need to know how a linked list works to be able to operate with it. So yeah, let's just jump into it. So this one's called add two numbers. You are given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order, and each of their nodes contain a single digit. Add the two numbers and return the sum as a linked list. Just like we're given two linked lists, we want to return our own linked list back. You may assume the two numbers do not contain any leading zero except the number 0 itself. So yeah, let's look at an example because I think that will be the most illustrative way to kind of gain the intuition for how we're going to solve this. So if you look at the first example, we have 2, 4, 3. Sorry, let me scroll down a bit so you can see the whole example. But this is just a string because it's essentially a multi-line comment in Python. But yeah, so we have 2, 4, 3, 5, 6, 4. So it tells us these are digits stored in reverse order. So we know that the two numbers we're actually adding are 342 and 465 if you just reverse them and combine them together. So let's think about how we would solve this if we were, let's say in a grade, I think it's like 2 or 3, you're learning how to add multi-digit numbers. Well, the first thing we do is we look at these last numbers, 2 and 5, and we add those two together. Okay, so let's just add those two together. So we get 2 plus 5 equals 7. We now look at 4 plus 6. Well, that gives us 10. Okay, well, we can't put 10 at the bottom because we're only supposed to put one digit every time we add two numbers together in the way that we learned how to do it as children. So we're going to put a 0 and then we're going to carry the 1. Okay, so that's one thing we need to remember is, okay, we have to remember the concept of carrying when we go to implement this. Well, then what we do is we add 3 and 4. Okay, that's 7. And then we're like, okay, oh yeah, sorry. We just remembered we have to carry the number that we got from our previous result. Well, that's a 1. So we get 1 plus 3 plus 4 is 8. So we get that the number is 807, which means we're going to want to return a linked list that's 708. So the nice thing about the way that they've given us these numbers is they're already actually in the order that we're used to adding numbers in. For example, in this 2, 4, 3, 5, 6, 4, well, when we just solved that problem, we started with the 2 and the 5 and we added those two together and we said, okay, we get 7. Now let's move on to the next two numbers. We looked at the 4 and the 6 and we said, okay, let's add these two. And we said, oh, we have a carry. Well, let's remember that we have our carry number, which is 1 in this case. It's always going to be 1 if you're just adding numbers. And, well, it's going to be 1 or 0. And 0 just means there's no carry. So we then go to our next two numbers, 3 and 4, and we add them plus our 1, and we get 8. So this kind of builds our intuition into how we want to solve this. Well, what we can do is first, I guess, let's have our result. Let's say head equals, and then our cur number that we're going to be looking at equals none for now. We're not going to assign it to anything. So now what we're going to do is we're going to say while we still have numbers or digits to add, so in this case, well, we still have 2 and 5 to add. So while L1 or L2. One thing we also want to remember is how much we're carrying. Well, we can just look at carrying as it's going to be either a 0 or a 1. And for our first pair of numbers that we're adding, our carry is just 0. So we can initialize that to 0. Then we say while L1 or L2. Well, we want to get the next digit. So we're going to set that to be equal to our carry. So if it's 0, then we're going to start it at 0. If the carry is 1, then we're going to start it at 1. And then what we do is we say, okay, if L1 next digit plus equals L1.val. And then we can move our L1 node to the next number. And we can do the same for L2. Next digit plus equals L2.val. L2 equals L2.next. So in this case, we have 2 and 5, and our carry is 0. So our next digit starts off as 0 because our carry is 0. If L1, well, we do have an L1, it's started at 2. Then next digit plus equals 2 in this case. And then we move on to the 5. If L2, well, we have an L2. So next digit plus equals 5. And then 5 moves to 6 in this example. So we now have next digit equals 0 plus 2 plus 5. So we have 7. So now it's our turn to, well, if we don't have a head yet, sorry, let me just double check. These values, they're going to be, and there's going to be at least one node, so we don't have to worry about nothing. So we're going to say if head is none, then we're going to set head equals cur equals list node. And then actually, before we do that, we need to figure out what the actual next digit is going to be. Well, since in this case, we're okay with 2 plus 5 because it just ends up being 7. But let's look at this case here. Well, we have 9 plus 9. That's 18. So we actually want to carry the 1. The way we do that is simply reassigning our carry to now be next digit. And then we can integer divide by 10. This is how you do that in Python. So if it's at least 10, then our carry will now be 1. And if it's not, we have nothing to carry, and we'll just assign it to be 0. So we can now assign our next digit to be what it actually should be, which is our next digit mod 10. I guess you can probably do mod equals to make this a little bit shorter. Doesn't matter too much. But now what we can do is we can actually add this here. And then if our head is not none, then we can simply do cur.next equals list node next digit, and then cur equals cur.next. Okay. Now we've gotten to the point where we no longer have an L1 or an L2, but we could still have remaining carryover. So we want to make sure that if carry is greater than 0, it's going to be 0 or 1, but it's nice to just have it just feels nice to have if carry is greater than 0, then we're going to say, okay, cur.next equals list node carry. And then we should just be able to return our head that we assigned at the beginning. We'll run this. Okay, so we have 708 0 0 9999999999. We end up getting 100099998. Yeah, I think this is pretty straightforward. But yeah, so for the 4 plus 6, for example, we got 10. So we set our carry to be 10 divided by 10. Well, that's just 1. And our next digit to be 10 mod 10, which is 0. So our next digit would be 0, just like we did when we were first adding the numbers. And we remembered to carry. So then we set our next digit to be equal to this carry, so we don't forget to add it. and then we add our L1 and L2 vowels, reset our carry to if we're going to be carrying for the next number, set our digit to be what it should actually be, and then append it to our list, our linked list. And then if our carry is still greater than 0 at the end, when we've added every pair of numbers that we can, then we make sure to just add that to the end of our list. So hopefully that all made sense. Please let me know if you have any questions in the comments. I realized I forgot to submit my answer on the last one, but there we go. Submitted that one. You can see some wrong answers here. It seems like I tried this before and got it wrong, just to prove that we're all human. But yeah, thank you so much for watching. Hopefully this was of help if you had any trouble with this, but this shows that sometimes you just have to take a step back and really just step through the problem, because this is just ended up being exactly how you would add numbers if you did have to, bring out a pencil or a pen and paper. Yeah, this ended up being a fairly easy problem once you realize that's basically the exact solution that you have to do, is just take it back to your roots from when you were in grade school and you didn't have your phone on you. So yeah, thank you so much, and see you guys in problem 3.